Hello and welcome to this section of the MATLAB tutor where we're going to continue working with calculus in MATLAB, and specifically we're going to learn how to solve limits or to calculate limits in MATLAB. So it turns out that there is an actual limit command that you can actually pass functions and actually calculate the limits and get MATLAB to go and see if it converges and what it converges to. So first, if we're going to do this, it's best to go ahead and define a function. So probably one of the easiest things you can do is let's go ahead and create a function called JSON, and we'll call it an inline function. We'll make it super simple. We'll say JSON is equal to x squared, and the independent variable is x. So there's our function. JSON of x is equal to x squared. So if you want to take a limit here, then see that we've defined the function no problem, but in order to actually do calculus, computations with it, we have to make this this x variable a symbolic variable. So notice we did this, it pops up over here, and then we have a symbol that we can deal with, and that's what's allowing MATLAB to go ahead and actually use the tools in its toolbox. So now what we want to do is the limit command. We want to take the limit of the function we've defined, JSON of x, right? Now we have to tell it the limits. So just because this is such a simple function and I'm trying to show you what we're doing, you're going to go from x, or x approaches, let's say 5. So this is the syntax for this command. Limit, you put the function in first, then you put x, because that's the variable that we're actually calculating in the limit. X goes to 5, or x approaches 5. Now since there's nothing special about this, it's just going to be 5 plugged into this thing. 5 squared is 25. So it's a very, very simple calculation. Let me clear the screen. Let's create a new function. We'll call it f. And we'll do something that you pretty much see in almost any calculus book. So we'll create a function called sine of x over x, right? And then the independent variable is x. So there's our function, sine of x over x. And now we want to calculate the limit of f of x as x approaches what? Usually you see it in your book as x approaches 0. The reason this is interesting is because when you put 0 in here, sine of 0 is 0 on the top, and then x is 0 on the bottom. So what you end up with is 0 over 0. What does it approach? It's hard to tell. But when you actually do the calculus and figure it out, this limit approaches 1. And that's something that you see quite often in a calculus book in the beginning sections when you start talking about limits. So basically you pass it the function, and then you put the variable x and you put what it approaches. Now let me retrieve that command and leave everything there, except let me go ahead and take this out. What we've been doing up until now is we've been defining the function and then typing the function name in here. But just want to let you know, just for full disclosure, I like doing it that way because it's to me a little more clear. But you can type the actual function directly into the limit command. So here we've defined in the first position here, we've defined put the function in here. X is already a symbolic variable, and then we're saying x goes to 0. So in the previous times we were using the function name. Here we can just type in whatever function we're evaluating. You can just avoid defining the function if you like and just type it into there, and you'll get the same answer. So when you're dealing with limits, you can define the function and use the name, or you can just type the thing in there. Alright, so let's do one more thing. Let's say g is equal to, let's go ahead and take a limit as x approaches infinity. Let's go ahead and say something like inline, let's do something like 2 times x to the third power plus 4 times x squared plus x minus 3. Okay, and let's take all this, let's wrap it in parentheses to be explicit, and let's divide by 3 times x to the third power minus 8, like this. And the independent variable is x. So it's a kind of a long polynomial on the top and a polynomial on the bottom. So we're doing g of x here, and you can see what happened here. When I typed it in, I put the quotation here, but I forgot to put a closing quote around my function. So let me retrieve the last command. That's what's nice about that. Let me put my little tick there. You can see MATLAB has changed the function to purple and then the independent variable to purple, so it should work fine. So this is my inline function, and if it doesn't look nice to you, you can just take a look at it like this. So I've got a polynomial on the top and a polynomial on the bottom. Now if I want to take this limit as x approaches infinity, I'm not really sure exactly what's going to happen, because if x goes to infinity, the top is going to go to infinity and the bottom's going to go to infinity. So it's tough to just look at it and figure out what it's going to do. But when you study calculus, you learn techniques to do limits like this. And so MATLAB knows about all those things. So let's go ahead and clear the screen. Let's put our g of x function back up there, and let's take the limit of g of x as x approaches. And when you want to use infinity, instead of just typing in a large number, just use INF like this. Okay, because INF means infinity. Anytime you use the words INF in MATLAB, it's going to know that you're trying to use infinity. So we'll calculate this limit, MATLAB will think about it, and the answer is actually a number. Notice that when you go to infinity, the top goes to infinity and the bottom goes to infinity, but they're approaching infinity at a rate that converges so that the total quotient of that guy is actually a fixed number. And you use L'Hopital's rule in calculus to actually figure all that out, but MATLAB knows about all that stuff. It does it all behind the scenes symbolically to figure out what the limits are. So that's basically how you take limits in MATLAB. Define a function, and then you do limit command function as x goes to whatever number you'd like. In this case, we're defining a function and then putting the label there. You could just type the expression here if you like. That's fine too. It's just whatever you're using and whatever you're more comfortable with. I like defining the function because I just think it's cleaner, but just practice it yourself. Get comfortable with it, because calculating limits in calculus is something you use quite a bit and something that will, aid you as you solve your problems and do your projects moving forward.